All right, so we're supposed to use long division to divide this polynomial. Now, x squared plus 3x plus 5 is divided by x plus 1. That means x squared plus 3x plus 5 is your dividend. So I'm going to write that down first. X squared plus 3x plus 5. Notice it's in descending powers order, so the square's the highest, then the x to the first, then the constant. It's not missing any terms, and what I mean by that, it goes from x squared to an x to the first, and then a constant. Everybody's represented. Divided by, the divisor is x plus 1. Again, important, it said use long division. That's why I'm doing this. This problem can be done using synthetic division, but I'm going to follow directions. So the first step, I asked myself, what do I multiply this x by to turn it into an x squared? And we know that is x. And I write the x right up above its like term, 3x right there. Now I use the distributive property. X times x is x squared. Again, I line up like terms. X times 1 is 1x. And I'm, once again, lining up like terms. The next step is you change the signs in your problem. So that's a plus x squared. I turn it into a minus. This is a plus 1x. I turn it into a minus. And I add down. X squared plus a negative x squared. Those cancel out. 3x plus a negative x is 2x plus 5, and I bring down the next term in line. Then I start the process over again. I say, what do I multiply x by to turn it into a 2x? And we know that's a positive 2, so I put plus 2. Once again, I'm lining up my like term. Next, I use the distributive property. 2 times x is 2x. 2 times 1 is positive 2. Change those signs again, make it negative, make that one negative because they were positive. 2x added to a negative 2x cancels. 5 added to a negative 2 gives me a remainder of 3. Now, I know I can't do the division step again. What do I multiply x by to turn it into a 3? That's not going to work out, right? Anytime the degree here, this is a degree 0 because there's no x, is smaller than the degree here, which is an x to the first, you know you're finished with your problem. Notice next, I ask you to write your answer as quotient plus remainder divided by divisor. So to do that, I'm going to say quotient, which is x plus 2, plus remainder, which is 3, over the divisor, which is x plus 1. Now if you want to check your work, you can take the divisor, x plus 1, and multiply it by the quotient, x plus 2, and then add 3. Ooh, not working. But that would be plus 3. So x plus 1 times x plus 2 added to 3 is going to give me x squared plus 3x plus 5. Okay, that's just if you want to check yourself. Next problem, we'll do a long division again. It's a big one, but it's not bad. Here is your divisor. Your dividend, my bad, and this is your divisor. Notice I have a 4, and then a 3, and then a 2, and then a 1, and then a constant. Once again, I'm not missing any terms at all. If you were missing terms, you know what to do. You put a 0x to whatever power you're missing in that position. It's like called a dummy variable. And it holds the position for you. So if you have a like term and you need to line it up under there, like for instance, if this it didn't have a minus 5x squared, but we had an x squared term, we'd have to have a place to line it up. So that's why we do that. Now in the front, you also want those in descending order. If they are missing terms, it's okay. You don't have to put the dummy variable there. Although if you did put the dummy variable there, you wouldn't be wrong. Okay, you could still get it done. But just more to think about, really. So what do I multiply this x squared by to turn it into a 2x to the 4th? Well, we know that answer. That's going to be 2x squared. Look, and I'm going to line that up right there above my x squared term. So 2x squared times x squared is 2x to the 4th. 2x squared times 2x is 4x to the 3rd. Notice, again, I'm lining up my like terms. It's positive, so I put a plus. 2x squared times negative 3 is negative 6x squared. So I'm going to line that up underneath the square terms. Sometimes, say you were missing a 2x here, you might have to skip a term to line up your like terms, and that's okay as well. So don't get concerned if you have to do something like that. Don't forget, change the signs. So negative here because it was positive, negative here because it was positive, positive here because it was negative. 2x to the fourth added to a negative 2x to the fourth, those cancel. 4x to the third added to a negative 4x to the third, hey, they cancel too, that's nice. Negative 5x squared added to a positive 6x squared is 1x squared, or x squared if you like that better. 3x minus 2. I just bring down all the remaining terms. Now I ask myself, what do I multiply x squared by to turn it into a 1x squared? 1, right? I mean, it's already there, so I need to put a plus 1 up here. Now, you could skip over, if I do it like the homework does, they would probably skip over and put plus 1, so my like terms line up. That's okay. 1 times x squared is 1x squared. 1 times 2x is plus 2x. And 1 times negative 3 is negative 3. Don't forget, change your signs. Plus turns minus, plus turns minus, minus turns plus. You add down 1x squared plus a negative 1x squared cancels. 3x plus a negative 2x is 1x, and negative 2 plus 3 is plus 1. Now notice the degree down here is a 1. The degree up here is a 2. Anytime your remainder is smaller than your divisor, you're finished. So this problem, if I write it out in the proper form, I'm going to do it in orange. Look at your answer up at the top. That's 2x squared plus, notice there's a 0x right there. I'm not going to put it because we don't need to write it, but that's what that implies when it skips, is that there is no x term. And then this, I'm going to put plus. Instead of writing 1 times x plus 1, I'm just going to put x plus 1 because those are the same thing, divided by x squared plus 2x minus 3. Again, I'm not going to check the problem here because I'm hoping I did everything right, and that's probably what you do too. But if you wanted to check it, you could take your divisor times your quotient, just using the FOIL method, which really is not FOIL, it's the distributive property because you have 3 terms here, and then add in x plus 1 at the end, and you should get this big dividend out of it. Okay, so that's long division. Let's try some synthetic division next. Alright, so we want to divide 5x to the fourth minus 2x squared minus 3 by x minus 1. Again, dividend here, divisor here. Synthetic division table here. Now how you draw that table is entirely up to you. Different people do it different ways. I do mine differently than our tutors, differently than the book. Just whatever you feel most comfortable with. But what's going to need to happen no matter what is across the top of a bar, you're going to need your coefficients, and they need to be in descending powers order. So notice I have a 5 to represent my 5x to the fourth, but I don't have an x to the third, so I have to put a 0 there. Not a 1, a 0. I do have an x squared. It's a minus 2 coefficient. I don't have an x term, so I need a 0, but I do have a constant term, and I mean a minus 3. If it helps you to write this with everything represented, 5x to the fourth plus 0x to the third minus 2x squared plus 0x minus 3. Notice everybody's represented. 4, 3, 2, 1 constant. And that's exactly the coefficients that go down here. 5, 0, negative 2, 0, negative 3. Next step, remember what goes out front, right? As long as you're dividing by x plus or minus a number, has to be that form, then you're allowed to take the 0 for this. So if I were to set x minus 1 equal to 0 and solve, I would get x equals 1. So that's what goes out front. Is it the same as just changing the sign? Yeah. But if there were a coefficient here, like 3x minus 1, the 0 would be 1/3. That would be what goes out front. But we're not doing those. But it does work that way. Okay. Now, the 5 first in line comes straight down. And then I multiply 1 times 5 is 5, and that goes into the next column, and I add down. 0 plus 5 is 5. Multiply 1 times 5 is 5. Negative 2 plus 5 is 3. 1 times 3 is 3. 0 plus 3 is 3. 1 times 3 is 3. Negative 3 plus 3 is 0. So this has a remainder 0. Now, That is not your answer, okay? You must go back and write your answer in correct form. The guys square off down here, that's the remainder. This is the constant. This is the x squared, x to the third. So my final answer is 5x to the third. This is the quotient. Plus 5x squared plus 3x plus 3. And the remainder is plus 0 divided by not 1, but x minus 1. Now, because the remainder is 0, there really is no sense in writing this fraction at the end. You are good right here. But if this were anything other than 0, you would have to write that whole thing there. Okay? Again, you could check yourself. You could multiply 5x to the third plus 5x squared plus 3x plus 3 times your divisor, which is x minus 1. And that should give you 5x to the fourth minus 2x squared minus 3. Next synthetic division problem again. I got my bar. Okay. My coefficients go across the top. Notice, is everybody represented? I've got a 4, I got a 3, I got a 2, I got a 1, and I got a constant. Hey, I don't have to add any zeros to this one, okay? So I've got a 1 that represents my x to the fourth coefficient. Negative 3 is my x to the third. Negative 5 is my x squared. Positive 6 is my x, and negative 3 is my constant. What goes out front? The 0 for x minus 4. And if I set x minus 4 equal to 0, I get 4. Okay? 1 comes directly down. 4 times 1 is 4. And I'm going to add that to that negative 3, and that's going to give me 1. 4 times 1 is 4. I'm going to add that to negative 5. That gives me negative 1. 4 times negative 1 is negative 4. Added to 6 gives me 2. 4 times 2 is 8. Added to negative 3 results in 5. Again, this is not my answer. This is just a trick to do division. You must write your answer out. So, remainder, constant, x squared, x to the third. Don't leave it like that either. Go ahead and write it out, y'all. So this is 1x squared to the third. I'm just going to write x to the third. Plus 1x squared is just x squared. Minus x plus 2. My remainder is 5. So that goes in the numerator over my divisor, which is not 4. My divisor is x minus 4. Did I give you too many synthetic division problems? Maybe I did. Okay. So, across the top, is everybody represented? 3, 2, 1, constant. Yes, they are. So, 2 represents my x to the third. Negative 5 represents my x squared. Positive 6 represents my x. And 3 represents my constant. What goes up front? 1/2. Is it as simple as changing the sign? It is, as long as this is a 1x right here. Okay? Alright, 2 comes directly down, so I have 2. Now, you can't do this with fractions, can you? Of course you can. 1/2 times 2 is 1. Negative 5 plus 1 is negative 4. Half of negative 4 is negative 2, right? 6 plus negative 2 is 4. Half of 4 is 2. 3 plus 2 is 5. Yeah, there's nothing up with that fraction. You can do that. Okay, go back and write your variables in. So remainder, constant, x squared. Final answer, 2x squared minus 4x plus 4 plus my remainder is 5 divided by x minus 1/2. There you go. How do you check yourself? Take that quotient right there, 2x squared minus 4x plus 4. Multiply it by x minus 1/2. You'll use the distributive property, add 5 to it, which is your remainder, and you should get this original dividend back. The last one I've got, and it is enormous. Okay. Do you want to do this one long division? I sure don't. Now, across the top, is everybody represented? I got a 6, a 5, a 4. I got no 3. Look, so make sure right here, you notice there's a 0x to the third going on. So now I have a 3, 2, 1, constant. Okay, we're ready. So I have a 4 for my x to the 6th, 20 for my x to the 5th, negative 24 for my x to the 4th, 0 for that missing x to the 3rd, negative 3 for my x squared, negative 13 for my x, and finally 30 at the end for my constant. What goes out front? Negative 6, right? Because the 0 for x plus 6 is negative 6. The first number always comes directly down. Negative 6 times 24 is negative 24. Added to 20 is negative 4. Negative 6 times negative 24 is positive 24. Added to negative 24 is 0. Negative 6 times 0 is 0. Added to 0 is still 0. Negative 6 times 0 is 0. Added to negative 3 is negative 3. Negative 6 times negative 3 is 18. Added to negative 13 is 5. And negative 6 times 5 is negative 30. Added to positive 30, and that gives me 0. You remember what it means when you get a remainder of 0? Well, it means x plus 6 was a factor of this big old degree 6 polynomial. So x plus 6 divided in evenly, which means if I were to factor this, x plus 6 would be one of the factors, right? So I worked my way backwards to write my answer. I got remainder and constant, x squared, x to the third, x to the fourth, x to the fifth. Another thing I want to point out, if you take an x to the sixth and you divide it by an x to the first, that's going to knock that down 1 to x to the fifth. Okay? Final answer, 4x to the fifth minus 4x to the fourth. Do you have to write these guys? You don't, because they're just 0. Minus 3x plus 5, same thing as the remainder. That's 0 over x plus 6, but we don't have to write it because it is 0. So there's your final answer there. Now here's an interesting problem that I do not care to touch without a calculator. I'm asking you to do two things. This is for the function f of x equals x to the fourth plus 5x third plus 5x squared minus 5x minus 6. Evaluate f of 3 the conventional way, the old way, the first way you ever learned to evaluate f of anything. Is my green working? Let's try. F of 3 is equal to, just plug it in, 3 to the fourth plus 5 times 3 to the third plus 5 times 3 squared minus 5 times 3 minus 6. Yes, you can just plug that right in your calculator just to be sure we're on the same page. 3 to the fourth is 81. 3 to the third is 27, so I'm going to have to multiply 5 times 27. 3 squared is 9, so 5 times 9 minus, that's 15 minus 6. It'll be 81 plus 5 times 27 is 135, plus 5 times 9 is 45, minus 15 minus 6. I keep going left to right, so 81 plus 135 plus 45 minus 15 minus 6, and I get 240. I'm going to check it one more time just by plugging this straight in my calculator and make sure I get 240 again. You should always take the extra 20 seconds it takes to plug in something twice. And after a brief pause, I found out, yes, I got 240 when I plugged it straight in. So that's what I mean by the conventional way, the traditional way, the first way we learn how to evaluate. Now, the second way, I'm supposed to use synthetic division and the remainder theorem. Can we do that? You bet we can. Okay. So synthetic division, I'm putting my polynomial coefficients at the top. Make sure everybody's represented. 4, 3, 2, 1, constant. Yes. So that means my coefficient of 1 represents x to the fourth. The 5 represents x to the third. The 5 for x squared, a negative 5 to go with the x to the first, and a negative 6 is my constant. What goes out front? This is what most people miss. They forget what to put out front. It's your number that you're evaluating. You don't change the sign in this case, okay? So the 3 goes out front just as it is. Now, 1 comes directly down. 3 times 1 is 3, plus 5 is 8. 3 times 8 is 24, plus 5 is 29. 3 times 29. Now, I like this method because you can avoid using a calculator, although 3 times 29 still makes me feel like using a calculator. I could do 3 times 30, which is 90, and subtract the extra 3 that I counted. So this will be 87. Negative 5 plus 87 is 82. I really don't want to do 3 times 82 without a calculator, so I'm going to use it. It's 246. 246 plus negative 6 is 240. Okay? Now, what's my answer? It's not all this. You're just supposed to use the remainder theorem. So that also tells me that f of 3 is equal to 240. Now, y'all, if you do this on the test, please know you're supposed to get the same answer. And if you don't, please figure out why you didn't. Okay? Check your work. Figure it out. All right. Problem 6a. We're supposed to list all the zeros of the given polynomials, and we are given a polynomial. Specify zeros that are also x-intercepts. And in a reminder, it says, remember that x-intercepts can only be real numbers. Imaginary numbers can be zeros, but not x-intercepts. So we're going to find zeros. We're going to find zeros by factoring, but really, honestly, the first thing you do is you set the whole thing equal to 0. Sometimes I leave out that step like it's just implied, but really that's what you're supposed to be doing. Now, it's partially factored, isn't it? But not completely. If you've got an exponent with your variable, there's the possibility that whatever polynomial you have will factor further. This is a difference of squares. It's x squared minus 4. Y'all know a difference of squares factors into a plus factor and a minus. The square root of x squared goes in the first position, which is x. The square root of 4 is 2, goes in the second position. So that's just that one factored. Hey, I got another difference of squares right here. Square root of x to the 4th is x squared, goes in the first position. Square root of 1 is 1, goes in the second position. Once again, a plus and a minus. Now this is completely factored, but this isn't. Now x squared plus 1, that's a sum of squares and cannot be factored further. X squared minus 1 can though. Look, that's another 2 sets of parentheses. Square root of x squared is x in the first spot. Square root of 1 is 1 in the second spot. Again, a plus and a minus. So, wow, we got a lot of factors here. And I couldn't factor x squared plus 1 any further. So I've got 1, 2, 3, 4. Those are called linear factors. And then I have this quadratic factor right here that I can't break down anymore. Now, how many zeros am I supposed to have? Like I got an x squared times the x to the 4th. That tells me right there this is a degree 6. Notice I didn't ask for the degree, but it is a degree 6, which means it has 6 zeros. So I need to have 6 answers down here when I get finished. Will I? Yeah. Okay, so if I set x plus 2 equal to 0, I get negative 2, right? And what I'm really doing, I'm going to erase this, but I'm setting x plus 2 equal to 0. I'm subtracting 2 on both sides to get x is equal to negative 2. I'm not just changing the sign. This is really what's going on. I'm going to do that for each one of these, okay? But when it's fast, then I'm just going to do it quickly. I'm going to get rid of that because I need every bit of space I can get, okay? So when I set x minus 2 equals 0, I get x equals positive 2. We'll leave this guy for later. When I set x plus 1 equal to 0, I get x equals negative 1. And when I set x minus 1 equal to 0, I get x is equal to 1. So there's 4 of my zeros right there. I got 2 more right here, right? Because that's a degree 2. Now, if I set x squared plus 1 equals 0, to solve that I need to subtract the 1 over. Because I can use the square root property. So I take the square root of x squared on the left, but whenever you add the square root in as a tool, you've got to put the plus or minus in front. So I get x on the left. Y'all remember what the square root of negative 1 is. That's I, the imaginary unit I. So if I list just the zeros, let's do this in orange. If I list just the zeros, I've got x equals negative 2, x is equal to positive 2. X is equal to negative I, I'm going left to right. X is equal to positive I, x is equal to negative 1, and x is equal to positive 1. Is that all 6 of them? You bet. Okay. Now, which one of those are actually x-intercepts? I'm going to highlight the x-intercepts, right? It's the real numbers. Negative 2, my highlighter's not working, is an x-intercept. Positive 2. But negative I and positive I, those aren't real numbers. I can't plot those things on an xy axis because the xy axis is the real number plane. Okay, so I only have 4 x-intercepts, but I have 6 zeros. Remember the rule? You can have up to the degree of x-intercepts. That's why I only have 4 in this case, because some of those x-intercepts are imaginary. Okay, same question, just a different polynomial. All right, again, notice I'm already factored, but not completely, because this is a quadratic factor because it's got the square in it, another quadratic factor because it's got the square in it. And I do know you recognize this is a degree 6. No, it's not. It's a degree 4, because if I multiply x squared times x squared, that's the highest exponent I'm going to get, which means I have 4 zeros. Doesn't mean I have 4 x-intercepts, but I might. I have up to 4. Now, to find zeros, remember the very first step really is to set it equal to 0, just to remind yourself what you're doing. I'm trying to find numbers that multiply to be positive 6 and also add to be negative 5. Now, anytime you multiply to be a positive number and add to be a negative number, both factors are going to be minus. So that's going to be x minus 3 times x minus 2. Does that work? Is negative 3 plus negative 2 negative 5? It is. Is negative 3 times negative 2 positive 6? Yes, it is. Okay? Now, this guy right here, unfortunately, does not factor. This is seeming really familiar. Did this show up on another review question? I believe it did. Okay? But I'm going to keep going with it. It does not factor. Does that mean you can't do it? Nope. You need to use the quadratic formula. Okay, so let's finish these two out. Don't forget what you got going on. X minus 3 equals to 0 and x minus 2 equals 0. That gives me x equals 3 and x equals 2. Okay, here, the quadratic formula doesn't factor for you. It finds your two zeros. So I have x is equal to negative b, so that's negative of a negative 5, plus or minus the square root of b squared, so negative 5 squared, minus 4 times a is 1 times c is 7. And that's all divided by 2 times 1. I keep simplifying. That's going to be a positive 5 plus or minus the square root of 25 minus 28. That's all over 2. So that's x equals 5 plus or minus the square root of negative 3 over 2. Hey, look, I got the square root of a negative number. You know what that means. That's x equals 5 plus or minus I square root of 3 over 2. And so that's my other two zeros. So x is equal to 5 minus I square root of 3 over 2. And x is equal to 5 plus I square root of 3 over 2. There's all 4 zeros. But which ones of those are x-intercepts? Let's highlight them. Right there and right there. Now if I write them in the form I'm supposed to, the x-intercepts, I didn't do this on the last problem, but I should have. The x-intercepts are 3, 0 and 2, 0. These guys right here, these imaginary numbers cannot be x-intercepts because they're not real numbers. You can't graph those. So the last of this type of question, although we got something very similar coming up next, list all the zeros of the polynomial. Okay, so the very first thing is, let's talk about how many it's going to have. I've got an x to the first, I'm trying to write that 1, an x squared and an x squared. That's not multiplied out. So if I were to multiply that, that would give me an x to the first times an x squared times an x squared. Remember, you add exponents when you multiply bases. That's an x to the 5th, which means this is a degree 5 polynomial. Also means I'm going to have 5 zeros. Now let's find out what they are. Okay, so you set the entire function equal to 0, x plus 5. Now x squared plus 9 does not factor. That's what we call a sum of squares. I know you think it does. Sometimes you think it does, but it doesn't. If that were minus, it would. This one is minus, and those are perfect squares, both of them, so it'll factor into x plus 4 times x minus 4. You see that trick so often, I know you have it down now. So right here, x equals negative 5 is one of my zeros. X equals negative 4 is one of my zeros, and x is equal to positive 4 is one of my zeros. Well, that's 3 out of the 5 of them. What do I do with this x squared plus 9? Well, I set that equal to 0. I subtract the 9 over. Now that's negative 9. I take the square root of both sides. But remember, whenever you take the square root of both sides, you've got to put a plus or minus. It just gives me x on the left. And y'all know the square root of negative 9 is 3i. So it's plus or minus 3i. If I were to list the zeros, so I've got them as x equals negative 5. It's kind of overkill with the list, but I'm going to do it anyway. Negative 4 and x equals 4. Then I got two more right here. X is equal to negative 3i. X is equal to positive 3i. See how those show up as conjugate pairs? The imaginary zeros always show up as conjugate pairs. Also true that anything that you have to use the quadratic formula for and you still have a radical in your answer. For instance, if square root of 2 is a 0, so is negative square root of 2. Always show up in conjugate pairs like that. So that's all 5 of our zeros. The x-intercepts, though, are just this one, and this one. And if I write them in point form, like I always like to see them, here they are. So these guys here are your x-intercepts. Okay, so problem 7 is very similar to problem 6. I thought I was out of it and do something a little bit different. But I asked for the multiplicity in addition to what I asked for in problem 6. Matter of fact, I think all the problems in problem 6 didn't have, their multiplicity was just 1. Now, I'm supposed to find the degree also. So remember, if this is x to the first times an x, this is x to the third, and this is an x squared. If I wrote that out, I would have a 5 from in the front times x to the first times x to the third times x squared. If I did all the work required, which will give me 5x to the 1 plus 3 is 4 plus 2 is 6. So this is a degree 6, which means it's going to have 6 zeros. But they might not be distinct zeros. It might be the same number over and over again. Okay? Now to actually find them, you set the whole function equal to 0. Now lucky us, this is already factored. Matter of fact, if I write it out all the way, this is going to get a little old. But when this has x minus 2 to the third on the outside, that really means there's 3 of them. Okay, when this has x plus 3 squared on the outside, that really means there's 2 of them. And if it helps you to write it out that many times, but whenever the square's on the outside of the parentheses, you just write it out that many times because that's what that means. So when I find my zeros, 5 does not give me a 0. Why not? Because really I could divide each side by 5 and it disappears. So 0 divided by 5 is still 0 equals all of those. So your coefficient in the front, or your constant multiple is often what that's called, does not result in a 0. And it is a factor, but you can't set 5 equal to 0 and get solutions. It has to be a variable. Now if that were an x out there, that would be x equals 0 as one of your solutions. But the 5 will not give you any of the zeros. Alright, now the rest of them. X equals 1 from the first factor. But look right here. X equals 2 showed up 3 times. So that has a multiplicity of 3. X equals negative 3 right here showed up twice. So that has a multiplicity of 2. Now, why does that matter? Because when you go graph it, if you have odd multiplicity, what's going to happen at x equals 2, the graph is going to cross over the axis like that. But when you have even multiplicity, even means 2, 4, 6, 8, not the number, not the 0 or the x-intercept, but how many times it shows up, even or odd. And this is even multiplicity. So over here, if you go to x is equal to negative 3 right here, what's going to happen is the graph is going to come down and touch the graph and go back the other way. So odd multiplicity, it crosses over the x-axis. Even multiplicity, it bounces right off the x-axis. Did I answer everything? I did. All right. So next problem. I know you know how to do this now. So what do we do? Okay, well, we've got to factor completely. Well, actually, we find the degree first. So from here, just from here, that's an x squared. From here, that's an x to the third. What about this minus 9x? It's inside with that factor. You take the biggest one. And from here, it's an x squared. If I multiply those together, I get x squared times x to the third times x squared. You add those exponents to get x to the 7th. Which means I'm going to have 7 zeros. Okay, might be the same number a few times, but I'm going to have 7 zeros. So let's write it all the way out. Remember, it's set equal to 0. So x plus 9 with the square on the outside means x plus 9 times x plus 9. Now this one doesn't mean you write it 3 times, because the only thing cubed is the x. But there I need to factor. You know, there's a greatest common factor of x right there. So I'm going to pull that out. And that common x out, and that leaves me with x squared minus 9, right? So pull out that x, and that leaves me with x squared minus 9. And then at the end, I have x squared plus 9. Now look, that'll factor more right there, y'all. So 0 equals x plus 9 times x plus 9 times x times x squared minus sign factors into x plus 3 times x minus 3, but x squared plus 9 does not factor further. Now let's write our zeros down. When I set this one equal to 0, I get x is equal to negative 9. When I set that one equal to 0, I also get x is equal to negative 9. Hey, don't forget to set this guy right here equal to 0. That's going to give you x is equal to 0. X plus 3 equals 0 gives me x is equal to negative 3. X minus 3 equals 0 gives me x is equal to positive 3. This guy right here is not 9, right, because it's x squared. So when I set x squared plus 9 equal to 0, I got to do work. I got to subtract the 9 over. I've got to take the square root of both sides. Remember, when you take the square root, you got to put the plus or minus. Y'all know what the square root of negative 9 is. It's plus or minus 3i. So I have x equals 3i, and I also have x is equal to negative 3i. Is that all 7 zeros? 1, 2, 3, 4, 5, 6, 7. Sure it is. Now, tell me about the multiplicity. Right here, negative 9 shows up twice. So negative 9 has a multiplicity of 2. 0 only showed up one time. Negative 3 only showed up one time. Positive 3 only showed up one time. You get the point. 3i only one time, and negative 3i only one time. Okay, so that the negative 9 is the only one that had multiplicity other than 1. Okay, folks, now it's supposed to find a polynomial that has degree n with the given zeros and function values. Woo! So what this means is right here, degree n means it's a degree 4. So when I finish with this thing, it's going to be an x to the 4th power is the highest power. Look, it has zeros of 3i and I. That's only 2 zeros, right? How many are you supposed to have? 4. Remember how those i's come as conjugate pairs? So if 3i is a 0, so is negative 3i. If I is a 0, so is negative I. There's all 4 zeros. So what do? So I call my function something like f of x. And I don't know what my leading coefficient is. I'm going to call it a. You could use any letter you want. Not x. Okay. And then I subtract all my zeros from x. Remember, if 3i is the factor, then x minus 3i is the 0. If minus 3i is the factor, then x plus 3i is a 0. Basically, it's always x minus your zeros. Don't forget that. In parentheses is x minus your 0. Okay? Not x minus the number 0, but x minus these values. Okay? And then next from here, that's x minus I. And then the last one in the list, that's going to be x plus I. Now, your ultimate goal is to solve for a and write this polynomial all multiplied out. And I've told y'all probably in class that often I don't require students to multiply all this out, but I'm going to because that's what the homework does. I'm going to do it in this video for sure, but you absolutely have to find a. And that's why you need this extra bit of information down here, the f of 1 equals negative 40. That helps you find a. But I think I'm going to multiply this out first and then find a. I think that'll be easier. So what do I mean? So I'm going to FOIL this. So I'm going to say x times x times 3i, negative 3i times x, negative 3i times positive 3i. Okay? The a still stays in front. And we'll deal with that later. Okay, so big bracket here. X times x is x squared. X times 3i is plus 3xi. Negative 3i times x is minus 3xi. Negative 3i times positive 3i is minus 9i squared. Excuse me. Let's go ahead and simplify it now. I was going to wait a minute, but let's do it. Look, those cancel. So that's x squared and negative 9i squared. Y'all remember what I squared is, right? I'm going to replace that highlighted I squared right there with negative 1, which is going to make this x squared plus 9 in a weird color. Let me go back and do that in red, y'all. There we go. Okay. Now, down here, I'm going to FOIL this out as well. So let me explain what I'm saying. X times x, x times I, negative I times x, negative I times I. So let's do it. So x times x is x squared. Read, y'all. Read. X squared. X times I is xi. Negative I times x is negative xi. Negative I times positive I is negative I squared. So down here, that's going to give me x squared. Xi and a negative xi cancel each other out. Negative I squared. Once again, I got I squared I'm dealing with. Y'all, what's I squared? Negative 1, right? Negative of a negative 1 is plus 1. Okay, this looks a little bit better. Do you know what I'm going to do next? I got to FOIL again. I got to multiply x squared times x squared times 1, 9 times x squared, 9 times 1. Let's do it. So f of x equals a. I'm worried about a later. X squared times x squared is x to the 4th. X squared times 1 is plus x squared. 9 times x squared is plus 9x squared. 9 times 1 is plus 9. And then add like terms. So that's going to give me a in the front still. And I'm going to use parentheses instead of brackets because it doesn't matter. X to the 4th. 1x squared plus 9x squared is plus 10x squared plus 9. Now that is my polynomial. Okay? Alright, now I'm going to add a page to this. No, I'm not. I'm going to go to the top of the page. I'm going to make this thing work. In blue now, I'm trying to find a. So what is this saying? It says when I plug 1 in for x, my 1 is going to be my x value, and negative 40 is going to be my f of x value. So I'm going to replace this with negative 40 equals, and a, I don't know, but I know 1 is my x value. So it's 1 to the 4th plus 10x squared plus 9. No, 10 times 1 squared. I could tell you to take out the x, and I didn't. There we go. Plug in 1s everywhere there's an x. Plug in negative 40 for your f of x value. So this is going to give me negative 40 is equal to a times 1 to the 4th is 1. 1 squared is 1 times 10 is 10 plus 9. Y'all, that's 20. So coming over here, almost there, negative 40 equals 20 times a. I move the a in the back. Divide both sides by 20, so a is negative 2. Okay? What do? I go down here and I plug in negative 2 for a, so it's negative 2 times x to the 4th plus 10x squared plus 9. You know what my final answer is? I distribute that negative 2 inside, so it's going to be negative 2x to the 4th plus 20x to the 3rd. How about minus 20x to the 3rd? I need to distribute my negative. And then minus 18. That is my function. And I should have called it f of x. Phew! It's a lot of number crunching. It's not hard. I know it feels hard after you do all that work because it's exhausting. But it's like going on a super slow run. It's just a whole lot of running, but it's just not super hard running. You know what I mean? So negative 2x to the 4th minus 20x to the 3rd minus 18 is a polynomial that has zeros of 3i, negative 3i, I, negative I, and also f of 1 equals negative 40. Yeah, this problem right here is really the same question as the last one. But they didn't give us the zeros, but they really did. It's from a graph. So it says find a polynomial of lowest degree. Okay. Now, this has only got 2 x-intercepts. So that means it's a degree 2. Not so fast, because it's got 2 turning points. Remember, the turning points is always 1 less than the degree, or up to 1 less than the degree. So this thing needs to be a degree 3. Okay, because again, it's got 2 turning points, and the degree has to be at the lowest number of turning points plus 1 more. Here's another way to look at it. Right here, y'all see that 0 or that x-intercept is x is equal to negative 4. See how it touches and bounces back the other way? That means it has even multiplicity. Not odd multiplicity, but right here it crosses over, and that's at x equals 3. It has odd multiplicity. Now, if it says find a polynomial of lowest degree, okay, that meets these conditions, well, the lowest even number is 2, and the lowest odd number is 1. So our polynomial would be f of x equals, now normally we have an a, but notice it says it has a leading coefficient of 1, so I don't have to put a there at all in this case. And I'm going to say x plus 4 twice. Why plus 4? Because remember, it's your x minus whatever your 0 is. And since my 0 is a negative number, it's x plus 4, and it's 2 of them because it bounces back. Here, though, I'm going to say that's just times x minus 3, and that's it. And what I should add to the directions is don't multiply it out. You know what? I'm going to do that. Before I post this, I'm going to say in these directions, don't multiply it out because we're just tired of multiplying stuff after doing problem number 8. I am anyway. I don't know about you. Okay, so this is a long video. It's like 46 minutes and stuff. So I'm going to chop this one out. I'm going to say it's done, and we'll come back and continue with problems 10 and see how far we can get before I make a really long video again. So the end of part 2 is now. Hope you're having a good day.